Hello, hello. Maybe. His is off. Okay, because this, I mean, I can't. Can you hear me with this? Is this thing on? Yeah, it's good? Okay. Yeah, we had mic feedback because I turned it on and it was like squeak, and I was like, oh no. They had to change. Yeah. He had to change this. It's on again. It's on again. Is it working? It's working. Okay.
Yeah, I'm ready.
Okay, we are going to start after solving our microphone feedback issues. Hopefully, they're gone. If any of you do have questions during or after the program, you'll have to use this microphone or it won't come off in the live stream or anywhere. So just, if you do have questions, just motion for me and I'll hand you this. I want to welcome everyone in the audience and everyone watching via live stream. I'm Kelly Haley, a reference librarian here at FPL. Half of you know me already. You know all this, and I'm happy to have Dr. David Peterson with us tonight to talk about some of the effects of climate change on the Buffalo River. Dr. Peterson joined the Ozark Society in 1978 and is currently serving as past president. I would like to thank the Ozark Society itself also for being willing to share their knowledge with us. They have done several programs for us over the last couple of years, and I really appreciate that. David Peterson spent a lot of time outdoors growing up in southern Wisconsin. He was a math professor for 38 years and used his applied math background in some of his hobbies and pastimes, which include creating wooden puzzles, those little wooden puzzles that you think you can solve and you can't. You make those, right? Building log cabins, stream hydrology, and the creation of mathematical models of the environment. He and his wife, Donna, who is also here tonight, hike on the Appalachian Trail 3 times a year on their way to completing the entire trail. That is quite a feat. Tonight, he's going to focus on just showing us some of the impacts of climate change on the Buffalo River. So I think it's easier to understand because it's closer to us and we're not looking at a picture of melting glaciers. It's something that affects us in a closer way. So please help me welcome Dr. David Peterson.
Well, thank you for coming today. I know a good share of you, and you show great courage by showing up again if you've seen part of this. But how many of us have been on the Buffalo River? So this is almost all of us, and this is just a really common sight, except that the fisher lady there, that's not me, so forth. It's not that common a sight unless that's one of my best pictures, I think. So over here you can see the Highway 14 bridge, and it's the water, the Highway 14 bridge is about 50 feet above the normal level of the Buffalo River. And here is the same bridge back in December 1982. It's just incredible. I know we've been out there when there's been high water, or you've been worrying about it, or you hear there's rainfall predicted and you've chosen your camping site so you have a way to escape just in case. In fact, probably we've been on there where we've scurried off the river before it came. But that is phenomenal, isn't it? 52 feet in. I don't know if you've scrambled, but the stream velocity there measured by the USGS was, and it depends on what part of the river you're on, but between 3.8 and 9.7 miles per hour. Actually, that's trotting along pretty fast. And that's one of the problems on the river when it rises is how do you get out? I don't know if you've done that, but oftentimes if you're floating in the middle of the river, even if it's high, you're pretty safe, but you just can't get off. You get in the brush and in the trees. So that's sort of that. And I put this in here, it's a private joke on my part, sort of, but this is the USGS concept of a flood, and this is the last 2 years of the level of the river. And so even though that 50-foot rise was exceptional, the Buffalo River gets pretty high on a yearly basis, like 25 feet. We read in the paper about people who have had to spend a couple nights hanging in trees or on ledges and stuff. That could happen anytime. But we're talking about climate though, and this is really characteristic. Spring peaks, but almost every summer it's pretty dry, really low. And I would say every summer there really aren't very many peaks. And we sort of know that too. You know, the canoeing season this year is about over almost. I haven't been on the river, but the average flow at Highway 65 for this time of year is about 400 cubic feet per second, but I just checked it when I came up and it was about 100. So even though we had a really wet spring, or 3 or 4 weeks of no rain, does it in pretty well. But here's my joke. The USGS, when do they start worrying about it? At 20 feet. They close the river at 10 feet, the park does. But they don't get concerned until it gets to 20 feet. A minor flood stage, 27 feet. I think that's ridiculous, actually, don't you? Just offhand. And then a major flood is 50 feet. So, but really, and this isn't so nice of me to say, there's not much to flood in the Buffalo River when you think about it. You know, there are some pavilions that surely will have debris in them and stuff like that, but it's not really, there are no towns that get washed away by a flood on the Buffalo River. So I will say some things that might sound skeptical about climate change today, but there is no doubt about climate change. This is the CO2 level in the top of the biggest volcano in Hawaii, where it's up at 13,000 feet or something. And CO2 has been increasing every year relentlessly, showing no signs. The world does greenwashing and stuff, but there's no sign of any decrease in the amount of CO2 in the atmosphere. And then the new figures came out and it went up 3 parts per million last year, which is higher than any other increase for about, well, higher than any other increase. It just is relentless. So whatever progress has been made, it hasn't shown up at one of the easiest places to measure it. Incidentally, these little wiggles have to do with photosynthesis in the northern hemisphere, where CO2 goes down a little, but then when the leaves fall off the trees and stuff, it goes back up again. So anyway, so I'm going to talk about water temperatures, discharge, that's a flow, air temperatures, extreme events, physical characteristics on the Buffalo River. And here is one of my favorite creatures, the alligator snapping turtle, and That's a typical creature. The professor, retired professor at Arkansas State's doing that. But when I prepared this lecture, I had a graduate student who wrote his thesis on alligator snapping turtles in one of my home streams, which is Cadron Creek, which is in Faulkner County. And but when I wanted to talk about the Buffalo River, I wasn't so sure that they actually had alligator snapping turtles in the river. There had been a survey by the Arkansas Game and Fish that found that the alligator snapping turtles were endemic in all but 7 counties in Arkansas. And the 7 counties that were missing were Newton County, Searcy County, and the other counties that the Buffalo River ran through. And I figured, oh, shoot, this won't work. But then I went on the internet and found out this picture from the Buffalo River where this barefoot guy and his buddy were hauling alligator snapping turtles out of the Buffalo River. And that figured, okay, well, they're there. But I also talked to a guy from Game and Fish, and he said he scuba dives there, and they're there. I have stepped on them when I've been wade fishing. But anyway, the interesting thing about this, we were talking about climate change. Some of it, what we're talking about is how does it affect animals and other things. And this is just one example. The alligator snapping turtles, and a lot of turtles are temperature-dependent sex determination, which means that, in this case, that the males are bigger than the females, but that's not the issue. It is that the gender is not determined until when the eggs are laid. It's the temperature in the nest that determines the gender. So if the nest temperature is at less than 81 degrees, nearly all male hatchlings. If the nest temperature is bigger than 87 degrees, nearly all are female hatchlings. And if it's the sweet spot is 83 or 84 degrees, in which case it's about 50-50. So when people are predicting maybe a 5 or 7 degree change in temperature due to climate change, it could be that alligator snapping turtles are in trouble. They'll have all females. Well, is anybody checking on that? I was interested in, okay, Game and Fish ought to be off on that and digging up nests and seeing what the temperature of nests are. The people I talked to in Game and Fish have never found a nest. They're pretty well disguised. They're along the alligator snapping turtles almost never leave the streams and just get out to nest, and they cover it up, and then the nestlings are on their own. So nobody seems to know.
And the nest is in water, I guess.
No, it's on the shore.
Oh.
They go off, find a sandy spot where there's probably a lot of leaves and branches and stuff, and dig it and cover it up. I've got turtles that are now laying eggs in my pond. This is about the time of year that they'd be out there doing that. So we don't know about Arkansas or the Buffalo River as to what might be the future, but turtles have gotten in trouble on islands in the Pacific and so forth when it's just exactly this. The nests have gotten too warm, so it's not a vacant threat. So at any rate, that's interesting, and I think up here in Fayetteville, I can see master's theses, PhD theses. There are lots of good projects to do for people in education. I put this in there primarily because it's pretty, but it actually means something. It's one of the problems with doing climate stuff is that you have a noisy signal. And so here I'll just point this out. At that date, which is just about right now, the temperature in the Buffalo River, 2 miles from the White River, in the water, was 54 degrees. And yet, on essentially the same date, on another year, it was 84 degrees. So the very same date, this time of year, it could be 54 degrees or it could be 84 degrees. Life is tough in the Buffalo River. I mean, if you think of hatching and needing certain temperatures to hatch, what happens and so forth. So this is 12 years of data that I got from the national park. And it's, if you've done the lower part of the Buffalo, I can tell you where it is sort of. 2 miles from the White River, there's a big rock. and the water sort of goes around it, and there's a concrete block at the bottom of it, and the sensor is right on the concrete block. That's sort of important, though, because it's a spot that won't be, if the water gets low, it'll still be in the water. It'll still have current in there, so it's pretty reliable stuff. You know, one of the problems is taking the temperature of a stream is hard, but the national park has it done. The problem with the national park is they've only done 12 years of that, and that's weather, that's not necessarily climate. So, some of the problems that we have with this is data collection has been sporadic. They just started it 12 years ago. Sean Hodges is the guy who's doing it. And the methodology changes over time. And even though the Buffalo River is 159 miles long, I know it says 152 a lot of places, but it's really 159 miles long. It seems big to us, but it's really small on the global scale. It's 2.6% of the watershed is 2.6% of the area of Arkansas. It's just a little sliver of Arkansas, really. So when we're talking about it, climate change, people are thinking about the whole surface, right? We know that in the Arctic and so forth, it's getting warmer than other places. That doesn't necessarily tell us about our Buffalo River. We'll just take a quick tour of the Buffalo River watershed. So here's Beach Creek, but that's Boxley over here. Here is Upper Mill Creek. That's where Bass Pro is doing their stuff. They're building their big amusement park. Marshall's over here someplace. Calf Creek runs in here, so forth. But the interesting thing, I think, is that this green area is limestone primarily. And that's where you get karst and sinkholes and all that kind of stuff. And this blue stuff here is sandstone mostly. But if you notice here, in the valleys, the limestone follows most of the streams, and most of the streams are not in sandstone, they're in limestone, which means whatever comes off, even from the sandstone, it'll enter the karst very quickly and have a quick runway to the river. So that's just the way the river, the geology goes up there. I couldn't resist doing this, which emphasizes that. Back when we were fighting the C&H hog farm, you know, people went out there and did dye tracing. They put dyes in sinkholes, just see where it all goes, right? And this is the epitome of karst, I guess. They put dye here, and these purple dots are where it went. It's just riddled with paths to the stream. Like, so how does the dye get from here over to there? It runs. This is a pretty big mountain, actually. It's about 1,000 feet, and somehow or other it got underneath there and went over there. And here's the most miraculous thing, I think. Some of the dye went over here, went underneath the Buffalo River, and showed up a spring on the other side. So, you know, my friends from the Buffalo River Watershed Alliance and so forth kept bringing up karst all the time, bringing up karst. But it's real. I mean, it's just like if you put something in a sinkhole, it could end up anywhere, right? And quickly.
Sure it's not migrating snapping turtles?
Pardon?
I said, you sure it's not migrating snapping turtles?
You know, that's interesting. One of the things about alligator snapping turtles I forgot to mention is they don't leave their watershed. They're in the water and they don't crawl over the mountain.
But they do cross the highways.
Yeah, you know, there've been, as you know, academia is always looking for something to do, and they've looked to see what the range of a typical alligator snapping turtle is. It's about 2 kilometers per year. They just don't move. They got a good place and they stay there. They're not going to Kings River. Okay, and here's forest and agricultural land. 14% of the Buffalo River watershed is agriculture. That means almost all of the Buffalo River watershed is really forest. Here, the red stuff is metropolitan areas. That's Marshall. See if you can see another red dot there any place. There just aren't many metropolitan areas in the watershed. It's really a nice watershed in that regard. So Calf Creek is here. I'll show you a picture of that later. There's something to be noticed here. You notice that there's not much agriculture here. And why is that? It's Leatherwoods Wilderness. Nobody's supposed to be in there. Only horse traffic. And here's another place without much. That's Richland Creek Wilderness. And then the Upper Buffalo Wilderness is up here. And there's one other thing. There's sort of a line across here. I don't know if you can see that like this. And the reason that's there is because that's where the National Forest is. So you can have agriculture in the National Forest. There's just not as much as every place else. So our friends in the National Forest do a pretty good job of that. Well, here's Calf Creek. And Calf Creek is just about 5 miles or 6 miles west of Highway 65. So, but at any rate, this is, bank full is this, about 6 feet here. Okay. And bank full happens on just about every tributary in the whole Buffalo River about every 1.5 years or 2 years. So when you're out there, it's going to happen sometime or other. It's going to come up here. He's about 6 feet tall, so it's at least 6 feet here. But this is characteristic. When you have a flood, there's erosion on the outside of a curve, and the gravel bars on the inside of a curve, always. There's no exceptions to that. It's just physics. The water on the outside of the curve is going faster. Have you played Crack the Whip when you were a kid? The person on the outside was going faster, right? Just really basic. And when you have a rise, what happens in the river? Well, one of the things climate change has to do with pollution. This is a rise on Big Creek. And virtually nobody ever measures, really, what happens during a rise in the river in terms of nutrients, like phosphorus or nitrate. This is a nitrate trail. So in this case, the river went up. This is Big Creek. But 150 cubic feet actually isn't very high. You could wade across it. This is like a 2-foot rise. This isn't a big flood. But still, there's a nitrate plume that formed here. The nitrate level from, this is ambient nitrate, up to there, it changed about a factor of about 50. So if you're a fish in Big Creek, you can go from nitrate low levels, normal, and all of a sudden it's 50 times higher. Animals have to be durable in many ways to live there. And there's a time lag here, about 5 hours, and I know why the time lag is there. It's because it was coming from C&H Hog Farm. The nitrate was washing off the fields. And the reason I know that is because the Big Creek Research and Extension team was also sampling at the same time, and they're doing grab samples, and that's what they got. There's about a 5-hour lag before it showed up. And so here's the nitrate levels jump up. That happens every time there's a rise. It isn't just turbidity that I calculated the nitrate load is about 700 additional pounds. And here's the real killer. E. coli went up to 4,600. The 3% infection rate is 400. So when you have these rises and you have things washing off fields, you don't want to be swimming there. That's all, yeah.
Are we seeing fish floating on top of water?
No, and no. The deal is, although there's a really significant nitrate range, the fish kill level is above 10. So it didn't get up to a fish kill level. And furthermore, we're blessed with really nice water in the Buffalo River generally. In places in Iowa, it gets up to 40. around some of their agriculture areas. It can be much worse. But that's one reason we were fighting the hog farm. It of itself maybe wouldn't damage the river, I really think. But if you had 20 of them, if this were happening on every tributary, it would have been a different story. So we figured that we should fight it. So anyway, here is a hog farm that doesn't exist anymore. It's not C&H, but I don't know if you can see this, but there are hogs in here. This is dark in here. Do you see it's darker there? It's because that's where they poop. So it was just that whole hillside, that's their recreation area. And you can just barely see it. There's a stream, a tributary to the Buffalo River that flows right through here. And that's actually, this is misleading a little bit, but that's not a whole lot different from historically the way hogs were raised in the Buffalo River watershed. Not as big as this, but every farm had their hogs. And actually, most of them went out of business just because even not doing a very good job of farming, they couldn't stay in business. This one went out of business also, and it turns out that DEQ took this picture. That guy named Garrett Grimes gave this talk a month ago at UCA, and one of the professors had him in class. It was sort of neat. Okay, there's my student. He took this picture and they closed it down. So I think that was good. Here is actually at C&H, and I just feel like we ought to see this picture. They wash down the hog pens about every 2 weeks, and the water flows out into a pond like this, and the stuff that floats goes to the surface, and the stuff that doesn't float goes to the bottom. And then every once in a while, somebody pulls up with a big tractor, and they pull water out of there. But it's really important where they pull it out, because if they pull it out of the top, they're getting mostly nitrate. And if they pull it out of the bottom, they're getting mostly phosphorus. And phosphorus is more a problem than nitrate is. So they're supposed to have a big mixer in there, like a blender. They're supposed to go with a blender and mix all that stuff up and then load up their things. But who's checking, right? So we don't know. Usually they have to be emptied out every once in a while. But the permitting system on these was that the limit of leaking on that pond was supposed to be 5,000 gallons per day. That's a lot of leakage. And if you could keep the leakage below that, you're okay. Actually, there's no way to measure the leakage. So it was just engineering design. Did you design it so it wouldn't leak more than that? And then some other things. Is there enough freeboard here so if there's a big rainfall, it wouldn't wash over? You know, those kinds of technical things. But at any rate, they're not supposed to have rocks in the levee and stuff like that. Now we're getting into some stuff that we might have an intuition in. Where, if you were to look for cool water in the Buffalo River, where would you look? What part of the river?
Next to spring or the deep holes?
Well, you go to a spring or something, or where the water's deep or something like that. But would it be cooler at Boxley or at Highway 65 Bridge or the Highway 14 Bridge?
Boxley upstream.
Boxley's upstream. We all think that being 1,000 feet higher would be cooler. We all know that air temperatures are likely to be cooler, right? And so maybe the water temperatures are too. And so I went and looked at it, and guess what? Here's Boxley. Here's January, February, and so forth. That's what those boxes are. And the clear winter for cool water seems to be Boxley, right? The blue. Particularly during the summer. During the winter, almost all the water is like 30 or 40 degrees. But during the summer, it's cooler. So it looks that way. But actually, this is one of the problems that you have there. I put this graph there to mislead you. The years didn't coincide. So the years that I took the temperature from Boxley were not the years for the other part of the river. And that's the way the data is. So you'll have 1970 and 1980 from Highway 65, but then they quit taking the temperature. Okay, well, we have that data, and you go up to Boxley, and it's a different span of different decade or two. So what do you do with that data? it's just tricky to draw those conclusions. Okay, and then I'm sort of, so here's the summer mean low temperature at Harrison. Instead of seeing here's a regression line. Instead of the temperatures just sort of like smoothly going up, what do you see there? Well, it looks like waves to me. It looks like the temperatures go like this, then go down, then go up, then go down, right? That's sort of like weather. That's not really climate, right? That's something's happening on a decade level. But actually, I sort of know what happens there. They moved the weather station between here and here. So the weather station's at the airport, and it just really can't be that in 2 or 3 years the temperature summer mean jumps 5 degrees. Climate just really can't do that. And so I know they moved the weather station. So if you have during the summer particularly, if you have your weather station in a sort of a low-lying area near water or something, it'll be cooler there. And if you moved it to a hill, it's just, you got to be careful of that. All right. And here's a couple more. This is some of you know Carol Bidding. Anybody know Carol Bidding? Pretty cool lady, and Chuck Bidding is her husband. She hired an airplane and went out and took a picture out of the door, so as far as I understand it. But here's Big Creek coming in, and it's turbid. Here's the Buffalo River, and it's not turbid. But if you were out going to collect water samples on the Buffalo River, where would you collect them? And USGS collects data along here. Where is a good place to collect it? Yeah. One of them is like, okay, I have to go collect data. I'm going to drive down here and pick it right there, right? But then you would miss the turbid water coming in from Big Creek. Or somebody told me, well, where you collect it is right here, right here, right here, right here, and right here. And actually, that's what you should do. You should do a cross-section. But then, if you're doing phosphorus, each sample of phosphorus costs more than $100 to process. So it gets like, oh, well, I don't know if we really want to do that. So it gets really be a problem. And here's also Big Creek. And so the water flows in here like this and goes like this. And BCRET, the team from Fayetteville, had their water sampling spot right there. And can you see the cows? So it's a place where cows water. And when cows water, they almost always dump something there. And so it just seems to me that the people at BCRET are very smart. But that wasn't the ideal place to sample. Okay, so here's getting to the nitty-gritty of climate change. Over the years, in this case, 60-some years, as the amount of water flowing through past St. Joe, that's Highway 65, has it really changed over 60 years? Has it? Climate change people might say it's increased or it's decreased or something, or has it stayed the same? We're going to have a vote. Let's look at the data. Over 60 years, what's the trend? It's really hard to say. Who says it seems to be increasing? Who says it seems to be decreasing? It's just really hard to say. That's where a statistician is needed. And so if you use a statistical technique, the best fit curve is that dotted line there. But it's almost impossible. I mean, we see it when we go float there, right? The high water or not so high water or whatever. We have no idea of whether the flow is increasing or decreasing just from observing. And actually, the Buffalo River, according to this, has increased 18% in 81 years. That's a lot. If that's true, if that's despite all the messiness of the data, if that's true, that's probably climate change. 18% increase is an enormous change in the flow in the river, if that's true. but there's a test to see if it's statistically significant, and it is too big. It's not really statistically significant, but I'll go on to the next slide. There's at Highway 14, it's almost an identical graph. Do you see that? Downriver 40 miles, it comes out about the same. And I'll go up to Boxley, and it comes out about the same. So now, what do you think? 3 widely spaced places on the river, and you have about 14 to 18% increase at every one of those 3 spots. I personally am convinced that the amount of flow in the Buffalo River has been increasing. Are you convinced? Well, okay, but if you're convinced that the amount of water in the Buffalo River has been increasing, what is the cause?
Is this ice melt?
Ice melt?
Way up, working its way down?
Could be.
More impervious surfaces?
Yeah, the surface could change, right? I mean, it's got 14% agriculture. What if they cleared more forest off there? And if you clear off forest and you graze on the pastures and keep it clean, you'll get much faster runoff. So historically, that's a really likely situation. Any other possibilities? Pardon?
Size of the trees in the watershed.
Yeah, the size of the trees. There's a lot of logging going on. If you eliminate some of the trees, you don't have the transpiration during the summer, the evaporation from the trees, for instance. There's another thing. The Forest Service has started burning a good share of their forest. Half their forest is on a 5-year cycle. And when you burn a forest, the runoff is faster. That's just what it is. And so there are lots of reasons maybe that you could cite for increased runoff. But, and I'll stop with the graph just for a minute. All of us are familiar with the Buffalo River. This is for college kids who haven't been in the river, I have to explain this. This would be when you're floating over the gravel, right? Then you hit a rapids and you have a whole bunch of fun for about 50 yards, dodging rocks and stuff. And then it's a deep hole, right? You could swim there, probably. And then that's good fishing right in there. And then it starts to get shallow again. And then it repeats itself and repeats itself and repeats itself. And still it's interesting to me. Every mile is basically this way, right? And it's just a whole lot of fun. But you notice that the gravel bars are always on the inside of curves. They're always there. Okay. So the question is, do scientists not have anything to do? So this is not the Buffalo River, this is the Mississippi River, and this is 8,000 years of data on the Buffalo River. And so this is in this stretch, this is the current path of the Mississippi River. But 500 years ago, I guess it is, this was the path. Well, we all know the Mississippi River wanders, right? But this is really surprising to me. This is about 10 miles. So the path of the Mississippi River is meandered about 10 miles along there. So the question is, does that happen on the Buffalo River? Well, you know the answer, right? Because if you've canoed the Buffalo River, you're coming along, and all of a sudden, you used to go that way, but it's blocked off. You have to go through this chute this time. And so the question is, has anybody studied that? Well, this is my study. This is taken on Big Creek, from a bridge there. And so much, it turns out the gravel bars move or get eroded. In Mount Judy, they come up there and bulldoze this off or collect it, and then it comes back. Because gravel moves down the Buffalo River. It migrates down the river. So it's sort of a hopeless task, except it would cover up the bridge if they didn't do that. Meanwhile, that's not very good for fish life in there or anything else. So here is the study by the USGS. And Here's the relative amount of gravel as you go down the river. And where's the most gravel? Right in the middle stretch, right where all the agriculture is. But it may not be because of agriculture. It may just because the valley is wider and flatter. You know, there might be other reasons. But there's, according to them, there's more gravel downstream. Here's valley width. The valley is really wide there. It's wide there. Here's how close to the bank are you, close to the bluffs are you. We know that it's fun to go along the bluffs. Here's sinuosity. Sinuosity is cute. If you take the river and it's got some bends in it, what if you took it at the end and stretched it out? How long would it be? What's the factor, the stretch factor, if you will? They checked all this, and I like this. At 80 kilometers, the Buffalo River is this wide. If you went down to 160 kilometers, it would be twice as wide. Nope, it just doesn't work that way. Humans tend to think of proportion, double something and you have a double the effect. It's twice as wide, but it isn't that way. It's, this width is, this is terrible to me. Log 2 times that. So, at any rate. So the channel doesn't follow usual rules, but there's sort of laws on it. And this is sort of overkill, but this is gravel bar migration. Way upstream, there used to be a lot of gravel, and now there isn't. So that's climate change for the things that are in that stretch of the river. There was a lot of gravel, now there's not. Why would that be the case?
Because the greater flows will push the gravel downstream.
Yeah, just move downstream, right? And then at the top of the river, you run out of gravel, right?
But it's still eroding above that too.
It is, yeah. Don and I were out there, and we saw a place about 6 miles from where the Buffalo River starts, and a whole hillside had caved in, and it's in the process of washing down. And it'll fill in that area, and then it'll move by, right? It'll go someplace else. And there's, well, the Parshas went with us too. Remember that? Remember that? We saw that place where there was a chasm where the bank was about to shed off. There'll be more gravel there. The gravel tends to locate itself where side streams come in, though, like Richland Creek. So we have 2 streams coming in carrying gravel, and they sort of slow each other down there, and they drop the gravel there. That's really the process. So the Buffalo River is really active. But back to climate change. If you look at extreme events, because that's part of climate change, the world is big. Isn't there a flood every night on the news? Someplace in the world? People drowning and running for cover and stuff. Have the extreme events increased over years on the Buffalo River? Well, this is up at Boxley, and this is the largest event in any one particular year. So sometimes the largest event isn't very big, and sometimes it's really big, but this is a 10-foot rise. I never measured the bridge at Boxley, but it's about 10 feet. So this says about every other year the water runs over the bridge at Boxley, if you've been there, and that's pretty interesting, I think. Here's bridge at Highway 65, and I will point out here that this is the big one. Remember 53 feet? That first picture? That's that dot. So that's higher than it's ever been on the Buffalo River dating back to 1940. But if you looked at the last 42 years, does it look like, this is stage, how high the water is, does it look like the big floods on the Buffalo River are increasing or decreasing? Well, my statistical analysis says they're decreasing the last 42 years. But it's not very significant. And if you're skeptical, you'd say, well, what if that weren't there? If the big one weren't there, but the big one were over here someplace, would that change the way the numbers come out? And the answer is yes, it would change the way the numbers come out. So you have to be really careful about your conclusions. And then this is for the whole 80 some years, there seems to be an increasing change, but it's not statistically significant. I just,
David, is there, I don't know, did you have data on, is there data, are there data on average rainfall over those periods?
mhm.
And then how that relates to discharge? I mean, that's a major factor,
Mhm.
because that's why that 1982 flood occurred
Mm-hmm.
in December.
Yeah, the average rainfall in the watershed with that big flood was 9 inches over a couple days. That's a pretty good rainfall. So that doesn't happen very often, right? Yeah, so this is just a curiosity. How does the USGS know how much water is flowing through there anyway? Do they actually get out there and, well, what do they do? How accurate is their data? Maybe they don't know what they're doing. Maybe it's plus or minus 30% when they give you a number. Well, what they do, this is really weird to me, they go out there and actually measure the flow for maybe that dot, and maybe this dot, and maybe this dot. They send a carriage across and they use radar to see how fast the water is going and how deep it is. They come up with a flow. And then one dot, and another dot determines a parabola. And every other thing you read about flow in the Buffalo River comes from that parabola. They never measure it. So it's like, oh, maybe, shoot, maybe what if they're wrong? What if they have the wrong parabola, right? But they readjust their parabola every few years. If a tree falls across a stream, maybe things change, right? So they do that. They're pretty careful. And that's why not all these dots are exactly on that parabola. But when they showed readjustments, and it's amazing to me that when they readjust every 2 or 3 years, they get basically the same parabola. That's why they feel good about it. They know they're pretty accurate. It's amazing. Parabolas are so valuable. Here's what Luke was talking about. Here is the precipitation at Harrison. You can't cover the whole watershed, but as the precipitation at Harrison increases, the yearly discharge of the Buffalo River increases. It's pretty obvious, right? Get more water in there and it just, of course it's got to wash down. Except, like, here was 28 inches of rain in the year and here was 52, but the discharge is the same. So it depends on lots of other things. It isn't just the rain. What could possibly influence this other than just the rain? Well, actually, we had a suggestion. It depends on when the rain occurs. If it's in January, February, and March, when there aren't trees budding and all that kind of stuff, whoosh, the water just goes downstream and you get a lot of flow. But if it's sort of throughout the year, you won't get much because the rain will sink into the ground and won't actually get to the river. So here, however, is the Harrison precipitation for 121 years. And although I said the flow in the Buffalo River probably increased 16 or 18%, the precipitation in Harrison only increased about 5%. So the answer for why there is more water flow in the Buffalo River isn't just because Harrison got more precipitation. It's other stuff. It's the other stuff we've been talking about, land use and so forth. So, and this, I know this is Little Rock. But at any rate, maximum daily rainfall, they did get 8 inches back then and so forth, but their maximum rainfall has not increased in Little Rock over all those years. It just isn't. But here is something that's topical. This is tornadoes in Arkansas, and I thought I'd put this in there. Because Little Rock just had a big tornado, right? Class 3, and not class 3. But at any rate, so Donna and I have gone down and we've helped people whose houses have been damaged and so forth, and it's phenomenal. There's a class 3 tornado, which is plenty strong. And the question is, over time, have extreme storms increased? So here's the number of tornadoes in Arkansas, and this is the blue dots. It's obvious from this data that the number of tornadoes in Arkansas have been increasing. Is that right? It seems that way, right? Okay, the blue dots. Here's the deaths from tornadoes in Arkansas. The deaths haven't increased. So increasing tornadoes, deaths have not increased. So is there an explanation for that or conjecture? Anybody care to dive in?
Better diagnosis of a tornado coming, usually you got more people.
Yeah, we get these warnings all the time, right? Look out, take cover if it comes. Do you have a place to safe place? That could be one explanation. Are there other explanations?
How many are reported tornadoes?
Yeah, recording tornadoes. You know, it could be like, well, I don't know. Are there really more tornadoes? Well, actually, I don't think so, because this is U.S. data, but actually it turns out Arkansas data is not different. Here's class 4 and 5 right down here, and they haven't been increasing in the United States. Here's class 2 and 3. They haven't been increasing either, but here's EF zeros and ones. They've been increasing apparently, but it's not increasing. What do you think's going on?
Radar.
Pardon?
Radar.
Yeah, they can spot them, right? The new radar came in the mid-1990s. So anytime there's a little spin in a cloud, they'll send a team out to see if there's a tornado there. And if it's an EF0, and you can, there was an EF0 went by our house a few years ago, not by our house, but within a mile. And there were shingles were distributed off a house going that way on one side of the tornado, and they were distributed the other way on the other side of the tornado, and you can deduce that it was a tornado, but it was an EF0. And there were some trees pushed over and some shingles lost, and a church had to repair their roof. Well, that would have not been reported sometimes. Yeah.
But wouldn't there have been, I'm so back on the increased flow in the Buffalo related to rain, it would make quite a difference depending on the nature of the rain. You kind of alluded to this, but if we're getting the total number of inches per year may be distributed in 10 storms of 5 inches, or a little bit of rain, and that'll make all the difference.
That's right.
In terms of the surge.
When I gave this talk at UCA to the biology department to a seminar, the faculty members afterwards came up, yeah, but you didn't tell us what happened during the season, how many big events we had, and that's true. I mean, you should look at that, right? Yeah. So at any rate, I did some other checking, and for instance, in the Buffalo River watershed, over about 50 years, 60 years actually, there were only 8 tornadoes in Newton County. Newton County is where the Buffalo River is. Newton County isn't barraged by tornadoes, or else they're not reporting them. One of the two, okay? Pulaski County, which is about the same size as Newton County, had 88. 10 times as many. So, that's curious, isn't it? How would it be that, why should Pulaski County have 10 times the number of tornadoes as Newton County?
10 times the number of people?
It could be 10 times the number of people. I mean, you have a lot of people watching stuff, right? And you have news teams out there that can go. Is the news team going to drive up to Pettigrew to see if there's a tornado out in the woods, or are they going to go 2 miles across town to check out their tornado that might have happened in Little Rock? It's a reporting issue, right?
The terrain's different too.
Pardon?
The terrain's different.
The terrain is different, all sorts of things. Like Scott County only had 8 in the last 60 years. Scott County is right on the Oklahoma border. Tornado Alley, they're in Oklahoma and they don't have any. Or did they just miss them? So at any rate, it's clear enough that EF0 and EF1s are now reported and weren't before, that's all. Okay. Water temperatures are really hard to measure, and here's why. Because if you measure this water temperature right here by the Highway 65 bridge and come back 3 months later, it might be dry there, right? So what are you comparing the water temperature to if when you come back, it's just different. And furthermore, we all know where the warm water is, right? In the Buffalo River, if the shallow water near the shore is where it's, if it doesn't have much current, is where it's going to be warm. So how do you take a representative sample of water and temperature in the Buffalo River? It's really hard. I told you about the big rock. That's one way. But this is from data from USGS at St. Joe at Highway 65, and it depends on whether it's January or July, right? But what I did is I put all their data for all their months on here, and then they're all different colors. Each month is different color. So I could trace each month simultaneously. It turns out that in all 12 months, the water temperature increased. So it's not seasonal. It's not January versus July or anything else. It's uniform over the year, water temperature increasing in the Buffalo River at Highway 65. It's just pretty convincing. I know this is a bunch of garbagey stuff, but if these are positive, that means it's increasing. However, USGS quit measuring temperature in 2005, so we don't know, right? Wish they wanted to be better funded. Here's another water temperature thing. I think I'll skip that. I'll go up to Boxley and talk about drought now, because that's another climate change issue, drought. And here is last year. So this is curious. There was a 2-inch rainfall, at least at the station in Boxley, and the Buffalo River there went up 4 feet. That's pretty nifty. 2 inches of rainfall, the Buffalo River went up 4 feet. But that's way up in the watershed. And then it got dry. Between here and here, about 2 months, it really didn't rain up there. So they were in drought. So this is the gauge height. Drought, there's almost no water running through there. And I don't know if you've walked the upper Buffalo, but during the summer, there's places where there's not any water flowing, really. And then they had a 4-inch rainfall, and it didn't go up at all. So why early in the year with a 2-inch rainfall, it went up 4 feet. Got a 4-inch rainfall, and it only moved about 6 inches.
The aquifer was charged earlier in the year.
Pardon?
The aquifer was charged.
Yeah, you know, it's just, you have 2 months of drought, the ground is dry, right? It just all soaked in. Didn't recharge the springs or anything else, you know, so just looking for major rain, just checking the rainfall total doesn't really tell you a whole lot. But here's the water temperatures at Buffalo during that same stretch. And normally during the day, water temperatures change about 1 or 2 degrees because there's sun shines on them or whatever. But during that drought, the water temperatures at that gauge were changing about 15 or 20 degrees. That's just a phenomenal change in temperature. And furthermore, the temperature got over 90, which would kill smallmouth bass, basically, kill most fish. Fish can't survive that unless they have a sanctuary someplace, unless there's a spring someplace, or they can get underneath a rock or do something. So that's what happens during drought. But you might think, well, last year was terrible, but actually that happens pretty much every year. You see this? This is the 30-year average here. And this is last year. It's not unusual. Those animals in the upper Buffalo that survive are really tough characters. Here is my favorite fish, a smallmouth bass. Do any of you fish? Anyway, here's their prey, darters and other things. But the deal is, the Buffalo River is way at the southern end of their range. So there's a danger that if the Buffalo River water temperatures go up, that they'll disappear. That fishermen go to the Buffalo River to fish because they're after smallmouth bass. That's just the truth. They won't necessarily die off tomorrow, but they'll be replaced with fish that are more acclimated to high temperatures. And so Dan Magulik and Middow did a study, 2018, and they were trying to forecast the effects of angler harvest and climate change on smallmouth bass. And their stressors were temperature, as we've seen, low dissolved oxygen, which I didn't do it, toxicity, which I sort of mentioned, hydrologic regimes, what we looked at. And their conclusion was increased flooding and drought indicate large reductions in adult smallmouth bass and increased probability of extinction. So that's pretty dire, right? So if you knew that and you believe the study, would you recommend that the game and fish fool around with the genetics of smallmouth bass so they can survive in warmer temperatures? I mean, those are the kinds of decisions that people are trying to figure out. If climate change is real, if the water temperatures are getting higher, they're really stressing out the bass, we really value the bass, should we genetically manipulate them?
I don't know, look at what ADEQ did with the carp.
Yeah, the grass carp, and see how that came out, right? So who's in favor of genetic engineering for smallmouth bass?
How about burning?
Pardon?
How about less burning?
Yeah, there's other things you can do, right? You can manage the land in different ways. Yeah, so that would be my solution. Yes?
I really don't know, but where does the buffalo start?
Starts at Red Star. Okay, if you take Highway 16 from Clinton and hope to end up in Fayetteville, you'll go past the Red Star Schoolhouse.
So it's within Arkansas,
Oh yeah,
but your other graph showed the northern part. Should be nice.
yeah, it's safely in Arkansas.
Oh, that graph is all in Arkansas.
Yeah, yeah, and so at any rate, I guess this is just a fun picture. Here's a person standing in the top of falling waterfall, and probably you've gone swimming there. That's one of the best swimming holes in all of Arkansas. If you haven't been there, you need to go there anyway. And when the water's up, have you boofed that in your kayak?
Have I?
Yeah,
I have not.
but people do it, right?
Yes, yes.
Yeah, so boofing it means there would be more water here. But you go up and then just go over it, and you go nose into it, and it's deep enough so you don't really get killed, and then you just go down, and most people do tip over, and then they have to collect their gear. It's a great swimming hole, and furthermore, the road goes right by it.
It's funner backwards because you watch the sky go away from you when you go over it.
Is it really?
Yeah, I'll be away.
Cool.
So anyway, that's a really precious place up there, and to give the Forest Service credit, that stream is eroding a road there, and they called the Ozark Society in to discuss how to fix the road with minimal damage to the environment. I thought that was a really nice gesture for the Forest Service. I thought that was exceptional. There's a lot of criticism of the Forest Service, but sometimes they're pretty nice. So at any rate, but actually this stream sort of looks like this when it's not going over that. It can be really, they're sporadic pools, and it's rocky. This is sort of worse than sometimes, but where, as a smallmouth bass, how would life be there if you got stuck in that particular pool? If you're out there and the water went down and it's death. The death rate of smallmouth bass in those streams is high. Here's discharge versus temperature. When it gets hotter in Harrison, the discharge, the amount of water in the Buffalo River, it decreases. You would guess that, right? A hotter year, more evaporation, fewer storms maybe. I'm going to skip that one. This is interesting because the nighttime, the extreme temperatures in Little Rock have not increased, but the nighttime temperatures have. That's not the temperatures actually, that's the cooling, degree days. You know what degree days are? It's basically how much you have to run your air conditioner. If you have to run your air conditioner because it's humid and it never gets below, say, 80 degrees at night or something, you run your air conditioner. And this is sort of what's happened in Little Rock. Before they had really good lot of air conditioners, didn't make much difference, but all of a sudden they have a lot of degree days and it's costing people. And we know that climate change can cost people. Here is sort of a conclusion. Does anybody recognize that spot on the Buffalo River?
Ponca Low Water Bridge.
It's the Ponca Low Water Bridge. That would be a bad time to put in. That's all I've got to say. That's what gives it away. There's a sign there that says, drive over here to put in, or something like that. I think this is a fantastic picture. This guy is a duck hunter from eastern Arkansas, and he was walking on thin ice, and guess what he saw underneath? An alligator snapping turtle. The ice looks to be about a half-inch thick, don't you think? I mean,
Oh, gosh.
that is incredible, isn't it? And I have a friend who lives in eastern Arkansas, and although it's illegal to trap, kill, or do anything else to alligator snapping turtles, they eat alligator snapping turtles regularly. So anyway, this is from NOAA, and this is Arkansas. This is from the whole state. They sort of average over the whole state. This is the temperatures over the whole state. And it sort of forms a sine curve here. You see that? And of course, it's noisy. That's what I've been talking about. These signals are really noisy. How can you predict? And if I asked one of my statistics classes and didn't show them all this graph, where do you think this curve would go? They would go like this, I think, wouldn't you? But this is what the modelers predict. It's going to go like this, and it's going to go off like this. It's not obvious. I trust the modelers. I think they have good mathematics and all that kind of stuff. That's the best scenario. Only about a 2 or 3 degree change. It could be worse. That's what everybody's afraid of, right? Would you want to be living in Arkansas 10 degrees warmer all year? It'd just be disastrous for agriculture and everything else. I do want to make one more parting shot, though, because right now in Fayetteville, or near Fayetteville, a judge is going to decide what the big chicken firms are going to do about phosphorus in the Illinois River. We're up here, and I guess most of you have seen the Illinois River and been on it, right? And that's a problem. This is from the Buffalo River, but that's what string algae looks like. But it can be lots worse than that. And here's a field with chicken litter in it. And there's about 70 tons of chicken litter there, and there's about a 70-acre field, and they're going to spread about a ton of chicken litter per acre there, and that's actually about right, actually. So this is from the Buffalo River, too. But the question before the judge right now is the algae problem caused by chicken litter? That's the big deal. 30 years after it became a legal issue, still a legal issue. Does chicken litter cause the algae problem? What do you think? It's hard to say.
The algae problem wasn't there before we started
Well,
spreading chicken litter on all the fields.
that's what the judge said. And after 212 pages or so of his decision, that was his conclusion, is that they're still not doing the right job. But I will say that Fayetteville here, at one time, was putting phosphorus out of their sewage plant at 150 times the eutrophic level of a normal stream. That's Fayetteville, where our major university is. Not continually, I'm not saying it continually, but up to 150 times. But they've improved that. Their limit now is 20 times. That's a real significant change. And
Is that what they're spreading on the hay fields, or is that what is actually getting into the water after it's been treated?
it's put on the hay fields, and then it ends up in the water. But if you read the apologists for the chicken integrators, one person testified that it came from auto exhaust. It's like, you testified in court that was, how does that work? And how do you get tons from auto exhaust in there? I don't know. But at any rate, it'll be interesting to see how that turns out. Bentonville is not much better. Bentonville is by far the richest county in Arkansas, 50% higher income than any other county. And they just fought the Department of Environmental Quality to raise their limit for phosphorus in the stream. And won, they have it. But they're much better than Fayetteville, it turns out, to their credit. So that's the end of my talk. Do we have any other conversation or questions? Yeah.
Let me give you the mic now that we actually.
Okay.
Do you have any, is there any data on, is there any data from, is that working?
From where?
Okay, from, like runoff from, four-wheelers and erosion that we see
Oh, yeah.
going all over the national forest.
Yeah. Every time you build a road.
But I'm talking about the huge increase in the traffic, like into the, I understand they're gonna now pave the road down to Kyle's because of increased traffic causing more runoff into
Yeah,
the river.
paving is better than gravel or dirt.
Right.
It's at Birds in the Mulberry. That's where the four-wheelers are.
Yeah.
There's just tons of them.
And there's
Yeah.
more traffic now ever.
Yeah, there'll
with
be
four-wheelers.
increasing traffic, and that's one of, nobody seems to agree with me, but I think overdevelopment in the Buffalo River is a real threat. When you get more and more people up there, you get more and more traffic, and you have more and more traffic, you build more and more roads, and you get more and more accesses, and the accesses on the river get wider and wider and longer, and all that kind of stuff. And you have more four-wheelers driving up and down the gravel balls, all those complaints. That just comes with more people.
Isn't sediment also considered a nutrient? Is that right?
Yeah, but only for water plants. It's also a storage area for
It was just a high school
phosphorus.
biology teacher that told me that, so.
Yeah, it's also a storage area for phosphorus. And so if you have a lot of phosphorus running off the fields or something, and the water goes down and you have this turbid water sitting over this field or along the shore, it drops down and it becomes sediment. But then it leaks back into the stream. It becomes a long-term gift, unwanted gift, yeah.
Yeah, we saw carp in Beaver Lake for the first time this year, and a new type of algae nobody had ever seen before. A really stringy looking, something's going on.
Yeah, DEQ has a algae hotline. So if you see something unusual with algae, you can call up there and say, can you come up here and check this out? And I think they want more input.
But then they'll find out the sailing club septic field probably is.
Well, yeah, I think they don't have a very big staff, so they're having a hard time with that. But one of the problems is cyanobacteria, and cyanobacteria can kill people, but the death rate in the United States is about 1 or 2 per year. So it's not a major threat, but that's what people worry about, one thing. Yeah.
This is way off topic, but I think a lot of people like to have an interest in this. If you hear anything, why Mike Mills has resigned.
I will say that the Ozark Society and Buffalo River Watershed Coalition met with Mike Mills, was it a week and a half ago, or is it basically a week and a half ago? And he was nice, and I will say that we had no cause. We were not involved. His resignation didn't involve the Ozark Society in any way or form whatsoever. We did hear a bunch of rumors today. We had a meeting, and oh, you know how that goes. Nobody knows is the conclusion, yeah. Except it doesn't seem as if it was a willing resignation. No, that's it, as far as we know. Anything else? Well, I thank you for coming here and listening to me. And I hope if you have suggestions to make the talk better, I wish you'd send them to me. It would be helpful in that regard. My goal is to go to colleges and universities in the state and give basically the same lecture.
We actually have program evaluation slips.
Okay.
On the side of the pencils you can drop.
Okay, well, that'd be nice. Thank you.
Are these slides available?
Yeah, I can send you.
Send all this to my paddling buddies. This was very informative.
Yeah, I can send you a copy. Just send me an email, and I'll send you a copy.
Great.
It's changing weekly.
You have a great delivery. Thanks.
Well, thank you.
Thanks, David.
You're welcome. So I did put a few new things in there.